Hi, in the previous video on rational root theorem, we have seen how we can use this theorem to determine the possible values for the zeros of a function. Now, the Descartes rule of sign helps us to determine the maximum number or the possible numbers of the positive real root and the negative real root which a function can have. A function can have either real root or complex roots. So the Descartes rule of sign tells us the possible number of the real roots which a function can have. Let us learn this through an example. We have a function f of x is equal to 7x to the power 6 plus 4x to the power 5 minus 3x to the power 4 plus 2x cube minus 2x square minus 2x and a plus 2. If this is the function given to us and we have to find the maximum possible number of the real roots, then how do we use the Descartes rule of sign here? Let us see. The first thing to figure out is the number of sign changes in f of x between the consecutive term. So let me write down the coefficient of the term. So we have 7, then we have a plus 4, it's a plus 7, plus 4, minus 3, plus 2, minus 2, minus 2 and a plus 2 again. Now let us see the sign changes that's happening between the consecutive term. So the first term is plus, the second is also plus, so no sign change. Here a plus changes to a minus, so one sign change. Then a minus changes to a plus, a two sign change. Plus changes to a minus, a third sign change. Then a fourth sign change happen here. So basically there are 4 sign changes in f of x. And the Descartes rule of sign says that the above function f of x can have at most 4 positive real root. A function can have a positive real root or a negative real root. So to determine the positive real root, we have to figure out the sign changes in f of x. So at most 4 positive real root, or it can have 2 possible real roots, or it can have 0 positive real root. Please remember that the number of possible roots always will be obtained by subtracting an even number from the number of sign changes. Here 2 is obtained by doing 4 minus 2 and 0 is obtained by doing 4 minus 4. So we always have to subtract the even numbers. And why do we always subtract an even number? Because a function f of x can also have complex root, which we sometimes obtain by using the quadratic formula. Okay, and the quadratic formula, whatever complex root we get through it, always comes in pair. They always come in conjugate pair. So if we have a complex root, there will be a pair for it. So there will be always 2 complex root or 4 complex root or 6 complex roots. Okay, so to take care of this condition, we always subtract the even numbers from the maximum number of sign changes. Okay, so to determine the maximum number of possible real roots or the possible numbers of positive real root, we find the sign changes in f of x. Now how do we find how many negative real roots can be there? So x, what was our f of x? 7x to the power 6 plus 4x to the power 5 minus 3x to the power 4 plus 2x cube minus 2x square minus 2x and a plus 2. This is our function. We have found the possible number of positive real roots for this function. Now to find the negative real roots, what you have to do is first find f of negative x. To find f of negative x, all the x will be replaced by a negative x. minus 2 times negative x and a positive 2. So here minus x raised to 6 gives you a positive x raised to 6, so it becomes this. Then you get negative 4x to the power 5, then a negative 3x to the power 4, then a negative 2x cube, negative 2x square, a positive 2x and a positive 2. And now you have to find the sign changes in f of negative x. So we see that the coefficients are negative 4, negative 3, negative 2, negative 2, a 2 and a 2. Now let us see the sign changes. So the first sign change happened here, positive to negative. Then no sign change, no sign change. The second sign change happened here. So the function f of x can have maximum or at most 2 negative roots, and in this case also we will subtract by 2, so we'll get either z2 negative root or 2 minus 2, which is equal to 0 or no negative roots. Okay, so we have determined what are the possible values of positive real root and negative real root for the given function fx using our Descartes rule of sign. Okay, so we have seen that we can either have 4, 2 or 0 positive real roots, and we can have 2 or 0 negative real roots. Okay, so in our next video we will see how do we actually determine all the zeros of the function by using the combination of rational root theorem, Descartes theorem and the synthetic division. I hope the Descartes rule of sign is clear to everyone. If you have any doubts, you can send me an email at kirti.mathacademy@gmail.com. This is my YouTube channel Mathacademy. If you have liked my videos, please don't forget to like, share and subscribe. Thank you.